Hello everyone. Let us now discuss how can we solve this problem. Lowest common ancestor of deepest leaves. As I mentioned here, this is similar to this question as it is, right? Smallest subtree with all the deepest nodes. So if we can solve either of this question, we can solve the both of the questions. Now, if I read this question, lowest common ancestor of deepest leaves. Given root of a binary tree, return the lowest common ancestor of its deepest leaves. Node of a binary tree is leaf if and only if it has no children. The depth of the root of the tree is 0 and the depth of a node is d. The depth of each of its children is d plus 1. Lowest common ancestor of a set S of nodes is the node A with the largest depth such that every node is in S is a subtree with root A. So if I take the same example, let me see clearly, explain you clearly that here I have a root node 3, right? My aim is to get the leaves and the parent or ancestor, which which is common to the to all the deepest nodes, right? I need to get the leaves and the parent or ancestor, right? So if I go left, I need to decide whether I need to go left or right. So here I have one depth, two, and then three. So here this node, if I say this node is having the depth of 3, but this node is having inclusively a depth of 2. Now, where will be the leaf nodes will be? That means the deepest leaf nodes will be at the subtree which is having more depth, right? This is having 3 and this is having 2. So if I go here, I don't find these nodes which are the deepest leaves. So that's why I don't go there. I would go rather to the deepest subtree. Now, that's my first intuition. First observation is something like go to the deepest subtree subtree, right? Or go to the node which is deepest or height is more, right? Now let us see. If I go here, what it would be happen. Now I'm at node 5. I'm at node 5. Now here also I have two subtrees. One is the left and the other is the right. Now, left is having 1 as the uh, depth and right is having 2 as the depth. Now, I ask you this question again, whether I need to go left or right. Go to the deepest subtree. Go to the node which is deepest or height is more. This subtree is having a height of 2. This subtree is having a height of 1, which is more here. This one is more. So I prefer going to node 2. Now, here comes the question again. Here, the left and right subtrees are having same heights. Now, this will be my answer. So, whenever I get a node which is having the left subtree height and the right subtree height as similar, then I will return the node as the answer or least common ancestor. Now, if the left and right subtree are having same depths or heights, then return that node as least common ancestor. Now, you might be asking something like, I got the same question, right? Here, what if I have another two nodes here? Another two nodes here, right? Now, imagine you are having these nodes as till here I got 8. So, I'll write here 9, 10, 11, and then 12. Now, the leaf nodes are 9 and 10. The parent for 9 and 10 are 7. But if I return 7, then I am missing 4, right? 11 and 12 are also at the same depth and also the leaf nodes. Now, why should I miss this 4? So, I cannot return 7 and 4. It is not asking for a vector in a tree node. It is just asking for a node. Now, if I return 4, then I will be missing 9 and 10 leaves, and I will be missing 7 as a subtree, which is the common ancestor for 9, 10 depths at 9, 10 nodes. Now, 11, 12 is having 4 as ancestor. 4 as ancestor. Now comes the question. What is 7 and 4 is having? 7 and 4 is having 2 as the node, the ancestor. Now, 2 is having no common, something like a common node, which is having something like here and here, and then here and then here, like this. So, if it is connected to another node like this, 5, then I will return 5 as the least common ancestor. So, then, if the left and right subtrees are having same depths or heights, then return that node as least common ancestor. So, my algorithm will be something like, first thing, I think you got what is this intuition how this works. Now, first thing, I will initialize least common ancestor globally. Now, I need to get I need to do a DFS, but I need to get depth of every node. So if it is having right node, if it is having right node, then it will be uh, then I would return something like return 1 plus get depth of node node right. Now, if node left is also having, then I will return 1 plus get depth of node left. So I will do a simple DFS here, and here I will be calling first thing I will be coming with the root node with this, and here I will be something like the main which is given. So I would call for DFS of node. Then here after that I will be after performing a DFS, I will return least common ancestor. Now what this do, here there will be left and right subtrees, right? If node left, then uh, then I will be doing something like left subtree and right subtree, the left depth and right depth. Left depth is equal to get depth of node left and the right depth is equal to get depth of node right. Now, if, as I said, the condition is if the left and right subtrees are having same depths or heights, then return that node as least common ancestor. But there might be a possibility that here I have only 3. That means 2 is having the depth of 3. But here 8 might be having more than 3. That means 4 or 5 as the depth for uh, for this node 8. And there might be leaf node. So instead of that, if right depth is equal to left depth, then I need to do something, that is least common ancestor will be equal to the current node. Now if right right depth is greater than left depth, then go to right node. That means I will call for a DFS of node right. Now else I need to do something, but before that let me write else if here. Else if else I need to do go to left node. That means call for a DFS of node left. That's it. This is how simple this question is. So let me explain you the code here. First thing, as I said, so these are the edge cases that if there is no root node, then I will return a null pointer. If there is no left and no right pointers uh, children, then I will return root node. Now find LCA. This is something like a DFS traversal. Find LCA of root. Now here it comes. Here this is the current node. Here I said it as node, right? DFS of node, right? Now if there is no left and no right, lowest common ancestor will be current node, and I'll return at that point itself. Int left depth is equal to calculate depth. Here I named it as get depth. In the code it is calculate depth. Now left depth is calculate depth of current node of left, right depth is calculate depth of current node of right. So how this calculate depth will be working? As I said, in the get depth function, if node right is there, but here's something like here we'll be calculating inclusive. That means here I made a mistake, right? Yes, I made a mistake. Come on. Yeah, this is the code for 1 plus maximum of these two. So instead of taking these something like here, you might be saying that here if you are having this node is having 2 and this is having 1, then that means here it is the left and here it is the right. This is having 2, this is having only 1. So the maximum depth for this node will be the maximum of, so that will be the maximum of left and right subtrees, right? So here the maximum of the left subtree and also the right subtree. So this is how you solve this problem. Now lowest common ancestor will be current. Else if left depth is lesser than right depth. Now, as I said, instead of DFS, I have named it as find LCA. Find LCA of current node of right. Find LCA of current node of left. So this is how you solve this problem. I have given the code link or the submission link in the description. Go and check it. If you like this video, do share it to your friends and do subscribe to my channel. Thank you.